Hello, my name is Madhukar. One of my greatest interests is data science. I created a basic model using scikit-learn in Python with the International Life Expectancy dataset from the World Health Organization. This model predicts life expectancy based on other data. This model is very simple. I have created much more complex models, but I did not make this complex, as that would make it very hard to explain. First, this section of the code imports all necessary libraries for this project, allowing me to use data science tools. This imports the dataset onto my computer. I removed some of the data that was causing issues. When creating a model, you need two sets of data: the training set, which is used to train the model, and the testing set, which is used to evaluate the model. This makes sure the model is actually predicting new data. This function also randomizes the indices, so no pattern in the order of the data can influence the model. I then split the sets again, separating X-train for the input and Y-train for the life expectancy, or the output. I did the same with the test set. Now we have the needed data sets. This here shows us the first 10 rows of the original data set. This here shows us the amount of empty values in each feature. A feature is another word for a column. These are what I first look at when I'm analyzing datasets for the first time. There are two issues here. One, there are many missing values, and two, these two features contain objects, aka letters, which these types of models can't use. I fixed these issues by performing three transformations to the dataset. The first one is called one-hot encoding. I did this to the features of objects since they are categorical. What this does is it takes each word, aka category, and turns it into its own combination of zeros and a 1. For example, if a feature only had three categories, the first would be 110, or the first would be 100, the second would be 010, and the third would be 001. Second transformation is called imputing, which fills in missing values with averages. The third transformation is called standard scaling, which is performed standardization on each column for easier processing. Now I can create the model. I used the random forest regressor to create the model, fitting it to the training data and making prediction on the test set. I calculated two accuracy metrics: root mean squared error and mean absolute error. Root mean squared error is sensitive to outliers, while mean absolute error treats errors equally. These are the two scores. These could be improved on through more advanced data science techniques, but I did not have time to explain those. I chose this topic because it's what I hope to eventually have a career in. Thank you.